This is your video for section 5.6. In this one, we're talking about the half-angle identities. So first, let's write out what these identities are. When we talk about a half-angle identity, that means we're taking an angle and dividing it by 2. And here's what they look like. For sine of a over 2, we have plus or minus 1 minus cosine a over 2. For cosine of a over 2, we have plus or minus 1 plus cosine of a over 2. So these two are very similar. It's kind of hard to remember which one is which. But they both have the plus or minus in them. And what that means is that it's possible that this could be either a plus or a minus. It just depends on the function and it depends on the quadrant that the angle a over 2 is in. So that's something that you have to determine for each different problem, whether it's going to be a plus or a minus on the outside of that radical. Well, let's use one of these formulas to find the exact value of the cosine of 15 degrees. Using some of the special angles we know, we can divide them in half and get values for some other angles. This is an example of that. 15 degrees is the same as 30 degrees divided by 2. So what we want to do here is use the identity for the cosine of a over 2. And our a in this case is going to be 30 degrees. Now for this one, when we're choosing the plus or minus, we already know what quadrant 15 degrees would be in. That's in the first quadrant. So this is going to be the plus. And then here we're going to have the cosine of 30 degrees. This is a value that we know. The cosine of 30 degrees is the square root of 3 over 2. We have the value now. The only thing left to do now is simplify this somewhat. So on the top of this, we could take and get a common denominator of 2. And then we could write this as one expression. So this would be 2 plus the square root of 3 over 2. And then down here we have 2, which is the same as 2 over 1. Then we could take the bottom part of this, invert, and multiply. That would give us 2 plus the square root of 3 on the top over 2 times 1/2. That's going to give us a 4 on the bottom. Since 4 is a perfect square, we'll be able to pull that out of the radical. What we end up with finally is on the top we have the radical 2 plus the square root of 3. On the bottom, we took our 4 and took the square root of it, so on the bottom we just have a 2. So really the hard part of this one is just simplifying what's under the radical. Let's look at a different type of problem. This time we've got a value for our cosine. We know what quadrant our angle is in, and then we're going to start out by trying to find the quadrant of theta over 2. Now an easy way to do this, if you already have this written as an inequality, if we want to do theta over 2, we could take this inequality and divide by 2 here. That means we have to divide by 2 in the other two parts of the inequality also. What we'd end up with is 270 degrees divided by 2. In the middle we'd have theta over 2, and over here we'd have 360 degrees divided by 2. That's going to give us 135 degrees, or theta over 2 in the middle, and then 180 degrees on the right side. Looking at our degree measures, we want to figure out what quadrant this is in. This is between 90 and 180, so this would be in quadrant 2. Then we're going to find exact values for sine, cosine, and tangent of theta over 2. And this was important because now we already know whether we're going to use the plus or minus for these two. In quadrant 2, sine is positive, so for this one we'll be using the plus, and cosine is negative, so for that one we'll be using the minus. For the sine, so we're going to have the plus on the outside of the radical, and then we have 1 minus cosine of theta over 2. We already know that cosine of theta is 3/5, so we're just substituting that in there. And then we're going to simplify this a little bit. 1 minus 3/5 would be 2/5. If we divide that by 2, we're going to get 1/5. So there's our sine value. For cosine, we're taking the negative of the radical since we're in the second quadrant. And then in here, our identity has a plus here instead of a minus. So here we would have 1 plus 3/5 when we substitute in our value for cosine of theta. That's going to give us 8/5 on the top when we combine those two, and then divided by 2, that would give us 4/5. Now we've got our value for sine and our value for cosine. To find tangent, we would just take the sine and divide by the cosine. The values we have are the square root of 1/5 and negative square root of 4/5. If we simplify that, we're going to end up with the negative square root of 1/4, which simplifies to negative 1/2. So that's our value for the tangent. In this example, we've got something that looks like the right side of one of our half-angle identities, and we're going to try to simplify this. So what we want to do is figure out which of the two identities it looks like, and then figure out what our A is. So because of this plus in here, this would be the half-angle identity for cosine. And then we need to figure out the A. In our identity, we have an A right here, so our A is going to be 12x. If we write out that half-angle identity for cosine, it looks like this. So where we had the A here that was the 12x, in here we're going to substitute 12x for the A. And then we can divide by the 12 by the 2, and that gives us the cosine of 6x. In this example, we've got an identity to verify. And notice this one involves some half angles. On this one, we're only going to work on the left side because that's the one that looks more complicated. The first thing I'm going to do is I want to multiply out this quantity that's squared. So I'm just going to write it out twice. And I'm actually going to use FOIL to multiply this out. So I have sine of x over 2 times sine of x over 2. That's sine squared of x over 2. And then I have sine times cosine. And then here I have cosine times sine. And then last I have cosine of x over 2 times cosine of x over 2, which would be the same as cosine squared of x over 2. Now what I can do with this, these two terms in the middle are actually like terms. They're exactly the same, just the order is switched. So I can combine those two like terms, and that's going to give me 2 sine x over 2 cosine x over 2. And then if I look at my first term and my last term, I've got sine squared of x over 2 plus cosine squared of x over 2. That's one of my Pythagorean identities. Since the angle is exactly the same in both of them, sine squared plus cosine squared is 1. So if I take these two and put them together, I actually get a 1. From here, there are a couple of different ways I could do this. I could use my actual identities for the sine of x over 2 and the cosine of x over 2 and multiply those two together. But also if I look at this, this looks like the form of one of my double angle identities that we talked about in section 5.5. This looks like the double angle identity for sine. That was that sine of 2a equals 2 sine a cosine a. So this looks just like that, where our a would be the x over 2. So that means if we've got this side of it here, then here we'd have the sine of 2 times x over 2, which would just give us the sine of x. So all of this right here is going to simplify down to just sine of x, and then that gives us what we had on the other side. So this part is kind of in between here where you have to figure out what this would simplify to.